Quick, graph y equals the sine of x minus 3 by hand, 2 different ways. This is part of the family of functions series. You will need paper and straight edge. We suggest you create grids similar to the ones at the right as needed. And of course, press pause as needed anytime during this video. First way is with the sine dance. Recall the graph of y equals the sine of x, one period of the wave. Note the 5 key points of interest. These key points and all of the points are affected by the parameters in the equation. The minus 3 shifts all points down 3 units. So the initial point, which is normally at the origin, is shifted down 3 to 0, negative 3. The x-coordinates are not affected at all. So let's plot 0, negative 3. The end of the first period is normally at 2 pi 0. It is shifted down 3 to 2 pi negative 3. Halfway between the start of a period and the end of a period is another point of inflection, usually at pi 0, but shifting that down 3, it goes to pi negative 3. Halfway between the first 2 points of inflection is a maximum, normally at pi over 2, 1, but it's going to be shifted down 3 to pi over 2, negative 2. And halfway between these 2 points of inflection is a minimum, normally at 3 pi over 2, negative 1, but now 3 pi over 2, negative 4, down 3. Pause is needed. Connect the points as a sine wave. Frown or concave down, smile or concave up. This is one period of the sine wave, and we want to duplicate the wave in the negative direction. So we'll go back a period, 2 pi in this case, from this maximum back 2 pi, from this point of inflection back 2 pi, and from this minimum back 2 pi. Again, connect the points, concave down, concave up. We'd like you to draw the line containing the points of inflection. That would be that line right there. And what is that equation? Pause is needed. The equation is y equals negative 3. And the question might be, where does that negative 3 come from? And comes from that parameter right there. Let's compare it to the parent function, y equals the sine of x. And you can see that from blue to green, every single point is shifted down 3 units, every single point. Or we can say that it's translated down 3 units. Pause is needed. Second way is with a table. So this is our normal table. Go ahead and complete it. Pause to do so. Those are our values on the axes. Create a second table. And the one parameter is subtracting 3 from each of the y coordinates only. We're keeping the x coordinates the same, so let's go ahead and just duplicate those. And now we're going to subtract 3 from each of the y coordinates. So 0 minus 3 is negative 3. And so we'll plot 0, negative 3. 1 minus 3 is negative 2. Pi over 2, negative 2. 0 minus 3 is still negative 3, but pi, negative 3. Negative 1 minus 3 is negative 4. 3 pi over 2, negative 4. And 0 minus 3, negative 3, 2 pi, negative 3. Connect the points as a sine wave. Concave down, concave up. So here we'll go back the period, 2 pi. This maximum goes back 2 pi. This point of inflection goes back 2 pi. And this minimum goes back 2 pi. Let's connect the points as another sine wave. Frown and then a smile. And there's our graph. Comparing that to the parent function. Now you try one. Graph y equals the sine of x minus 1. Use either method or both for the practice. Pause is needed and resume when you're finished. And here's the graph here in green, and you can see compared to the blue parent function, every single point is shifted down 1 unit.